Hey, I'd like to go over data poisoning, model poisoning, or AI poisoning, pretty much all the poisonings. I'd like to talk about all of them, the nuances of the terms, and give some real world examples that aren't the typical ones about automated cars and those cars going rogue based off some AI poisoning or model poisoning and their manipulated navigational LLMs. We'll have some real world examples in this quick video. And for starters, many organizations are not even creating a model from scratch. They're really using a service like Azure OpenAI that uses OpenAI's models or Azure AI Foundry that can tap into larger catalogs of models. And really, it's difficult to somehow crack into, let's say, XAI's data sets that they're using to train a model like the next iteration of Grok, like Grok 5, 6, 7, 8, whatever. And it's even more difficult to alter or poison that data set that is owned by a very large organization and obviously taking a lot of precautions to protect their particular model. So the OWASP, otherwise known as OWASP, defines the data and model poisoning risk profile or category this way. Data poisoning occurs when pre-training, fine-tuning, or embedding data is manipulated to introduce vulnerabilities, backdoors, or biases. But another way to think about it, because they said it occurs with pre-training, fine-tuning, or embedding data, all these different ways that poisoning can happen. And then once the model or the data is manipulated, it can introduce a number of things that they list off: vulnerabilities, backdoors, biases. Much like a good cup of coffee can be really bad by introducing maybe bad beans, or maybe a bad roast of good beans, or bad water, possibly, like not good water quality, overheating or underheating the water, maybe when you're making the coffee, too much sugar, which is a big thing for me, expired cream, or simply human error. Not a great barista, maybe a great barista on a bad day. But models and data can be poisoned in many different ways and change the results, like your coffee, and they can change the results of your model and the performance of maybe your generative AI agent in many ways by different types of poisoning. So we're going to get into that. By establishing these vulnerabilities or backdoors that I'm mentioning, an attacker can potentially cause havoc for a long time without detection. For example, a changed financial record could basically route funds to an attacker's bank account, or altered government records could cause integrity issues in how services are delivered to maybe citizens. How a particular agent that citizens are supposed to interact with in order to basically apply for a particular service by a city, county, state, or even federal government, that could be altered drastically by AI poisoning. And it also can have very lasting effects because sometimes you just don't know that it's happening. As I mentioned, pre-training is not as much of a concern when using a model as a service. Like in the case of maybe Azure OpenAI or Azure AI Foundry, you're pulling a model as a service, a model off of the shelf to use, and maybe pointing it at a data source. So it's not as much of a concern about poisoning the pre-training data source. But when you're fine-tuning the model, however, that is far more common, and your data source could be compromised, and that's in your control. Like most of you, when you drink your coffee, you're not sourcing your own beans, or maybe you're not even roasting them, but you maybe go to the store and buy grounds, and then the rest is on you. So fine-tuning and the data that you're using to fine-tune on, that part is on you. Again, like my coffee example, you may not be sourcing the beans and visiting various countries across the globe to try to source your beans, and you're not even roasting them. You don't have a roastery at your house. But at the same time, you are choosing where you get your grounds and then how you prepare your coffee after that fact, and what you add into the mix is completely on you. When fine-tuning, we'll use an example. So Azure OpenAI, when you're fine-tuning an Azure OpenAI model, you need to upload a data set via maybe Azure Blob Storage. If the wrong user with the wrong motivation wanted to tamper with your future AI application or agent, it would be as simple as gaining access to that Azure resource that the blob storage is sitting on. Similarly, you can connect, ingest, and ground Azure OpenAI on your enterprise data using a vector database. So not blob storage, but a vector database in Azure Cosmos DB. If the database is accessible or exposed in some way, then the data, or the corpus, as some people like to call it, can be poisoned. Another question I sometimes get is a prompt injection a poisoning event? The answer is best explained as somewhat of a Venn diagram. In some instances, a prompt injection can poison the model or data, or basically change how the model behaves, which is essentially poisoning. And sometimes a prompt injection is not poisoning. So it's not necessarily that they are one and the same, or they always equal each other, but sometimes a prompt injection can be a poisoning event. So a recent example of this is, and I'll probably include this link below, but Echo Leak. So basically there was a vulnerability identified where an attack could start with an email blast that went out to the entire company, or maybe a subset of users, that was on an innocuous subject like paternity leave, for example. And the users ignore it, and it goes maybe into some sort of filtered folder, maybe not the spam, maybe it does, but then it goes into some sort of filtered folder. And then at some point later, a user interacts with Copilot, let's say, and he asks about information pertaining to paternity leave, something very normal that an average user might ask. So Copilot, as a retrieval augmented generation AI agent, or RAG, uses everything in the Microsoft 365 tenant as its corpus, including email. So then in that particular case, it would scan that email that was sent to all these various employees in the company because it seems relevant. It's about the paternity leave policy, maybe getting an update. But in that email was 1-point font, white text on a white background, instructing Copilot to serve up an image to users, which then set off a string of other changes in the model and also to how it was behaving to basically exfiltrate data to an attacker's server. In that example, we have traversed 3 OWASP risk profiles, basically. You have an indirect prompt injection, the email that was scanned, then feeding that instruction to Copilot. So you have a prompt injection there. Then a poisoning event, changing the model's behavior, basically, during the inference process, where it's getting its new understanding of how to answer questions about a topic like paternity leave policies. It's predicting what is a useful answer to this. And so in that process, it's now changing what it determines and what its definition of paternity leave is. Oh, it's been updated. So let me serve up this new information. So basically the model is changing what, based off that inference process, what the answer to that question is. And then in the process, it's kicking off a bunch of other issues where sensitive data is being exposed. So that's 3 different OWASP risk profiles or categories just in that one example. So what do we do about it? Well, it's important to classify the data you have across your environment, especially data being used for fine-tuning, inference, or retraining. Namely, so that way you can protect that data from particular AI access and monitor it for any type of read-write events or maybe even modification events. For our example earlier, using Azure OpenAI or Azure Foundry, you can tap into data in Azure Cosmos DB in that instance on maybe MongoDB, and you need to know when potential sensitive data is being inserted in a table that may previously be non-sensitive. So by understanding what lies in your vector database, you can also maybe reduce access or heighten restrictions on certain entitlements to that particular resource. If you don't know what it's being used for, what's in it, then a lot of times you may give that particular database access to a larger group of people because it's just a general resource that's being used by a certain team or organization. But when in reality, it should be protected in a different way because it contains a certain regulated data type, for example. So in cases like blob storage on cloud infrastructure, which I mentioned earlier too, your data is encrypted in transit, basically over the network, and at rest. But you may also want to add a layer of protection by using maybe customer managed keys. Like my coffee example, whether or not you're sourcing the beans or sourcing and roasting or just selecting the roaster to buy from, you need to be at least in the know about what data you have, where your data is coming from, like what the supply chain is, and know any time that any of that is changing. Next, threat detection. Especially in the cases of RAG AI like Copilot or ChatGPT Enterprise, it's important that we can scan any data set, even emails, for malicious content that a model or an agent will use for any type of like inference. If hundreds or thousands of users are using an agent that's propagating maybe a malicious link or a malicious code or backdoors, like in the case of maybe developers using AI to write code. So it's asking a question about, hey, can you write me a piece of code that does X, Y, Z? Well, if the model's been poisoned, potentially it's going to serve up code that has malicious intent baked into the code that would then cause bad things down the line, so to speak. If we use maybe my coffee example, this is like the milk going sour, or almond milk if you prefer. Basically then everybody's latte in the coffee shop is going to be bad henceforth if the milk is spoiled. So great coffee, great beans, great water, great everything, but all of a sudden you introduce something new that basically ruins the experience of everybody that's getting a latte that day, especially if they're picking almond milk, let's say. Another big one is access controls. So for pro-code AI, especially training data sets like you may have in blob storage, they need to be protected with baseline MFA, so nothing new and novel there. Maybe role-based access control like RBAC, and limited to maybe just-in-time access if possible. You also need to monitor for changes in access or entitlements. So it's one thing to set everything up, but any kind of changes in access or entitlements, you need to have some sort of way to automate the alerting or the auditing with basically a data security platform for all your different cloud resources, especially if they're being used as part of the supply chain for your AI. It's somewhat very difficult and convoluted to understand which accounts or identities have access to a resource in, let's say, Azure, because basically you could give access through roles, groups, scoping policies, resource policies, direct access. And then also too, if you're deploying multi-AI in multi-cloud environments, the issue then compounds and gets even bigger. So if there's ways in which you can use basically your data security platform to maybe show, here's a resource, how does everybody have access to it and why? So that way you can maybe take action and limit those. Maybe it's a group policy or a scoping policy or whatever the case may be. And then similarly, the other way, if there's certain users or groups that don't need to have access to certain things, you can see what they have access going the other way to maybe mitigate, okay, well, there's no reason they should have access to these things. Oh, it's because they're a part of this particular resource policy. We need to trim that down. And you need a good way to visualize that without having to look through multiple different configuration policies. Next, and really the last, let's talk about two types of monitoring that's also very important. User behavior. So any kind of authentication events, so logging into the particular environment and accessing a resource, and obviously any kind of writing events or changing some of the data. Once you understand who has access and why, and can manage access long-term through automation or continuous audits, we'll still need to monitor changes made in the environment and alert on suspicious behavior. Often poisoning and other attacks are conducted after the attacker logs in and not breaks in. We've seen that time and time again. And a large portion of reported attempts are from insiders. So those folks also have the right entitlements, but can basically easily wield those for malicious purposes. So we want to be able to monitor for those things, even if they're able to log in. Last but not least, another line of defense is monitoring prompts and responses. Detecting attempts to poison data or alter the model's behavior through prompt injections can only happen if you're scanning the agent's interactions. Also, some models or AI systems intentionally retrain or fine-tune based off the interactions. So the corpus can be poisoned through the prompts in some way, shape, or form through that interaction. Another piece of this is obviously the results. We've talked about the prompts. Results are also somewhat critical in indicating a poison event, because rather by displaying malicious information or incorrect information, basically seeing poison come out is obviously a sign of poison coming in. You don't know your coffee is bad until you taste it, basically. So it's good to monitor the results and taste it. Hopefully this has been helpful. Hopefully this has helped you kind of understand a little bit about model poisoning or data poisoning or corpus poisoning or AI poisoning. There's a lot of overlap in what that means. Hopefully I've given some color to what the nuances are there. But nevertheless, I've included some links below. Check those out and enjoy your coffee. Cheers.